Is everyone ready? Okay, cool. So, welcome to day 5. This is the last day. So, feeling pretty good, like pretty loose. We've gotten a lot of things done, very productive. And I think today will be the most productive because what I'm going to try to do is just show you a hodgepodge of things, or an ensemble of different techniques. And unlike the last few, like as I said yesterday, I don't expect you to follow along. You may be able to try, especially if you have, if anyone happened to already sign up for a Paperspace account. Did anyone sign up for Paperspace? So lots of you did. And did any of you actually already get permission to use the GPUs? Okay, so that's one thing that will hold you back. In any case, like this, as my understanding is, this is all being recorded. So the tutorial I'm going to do right now starts from entirely public resources. So if you have the recording, you should be able to recreate all of the steps just by following what we do here. So I'm thinking that that's going to be the best course of action, and I can kind of go through things relatively quickly, so then later when you're watching it again, you can hit pause and kind of proceed with things. So yeah, so what I'm going to do is I'm going to show you a few techniques, and here are the ones that I'm thinking to show. I want to show you how to do char-rnn, which is a fun way of doing text bots. We talked about them briefly yesterday. And I want to show you how to do neural style transfer and texture synthesis, which are closely related. And then pix-to-pix, and possibly cycle again if we have time, which is also something that I showed you briefly at the end yesterday. And so I'm just going to show you like the main repositories you can use online that have the code that you need, and I'm going to go through a few examples, just basic, giving you basic templates how you could actually do like the basic thing, and then of course from then it's infinitely extendable. You can just apply your own creativity to it. Now this can be done in any computational environment which has the sufficient resources. So you basically need a computer with a good GPU. And my MacBook here is not good enough, and I suspect most people's aren't able to do most of this stuff. Some of you might have computers that can, but otherwise I usually end up using either cloud resources, or I actually have I have a computer back home in Germany that basically has what I need, and I share it with lab mates. There's all sorts of like clever ways of making this practice more sustainable. The cloud stuff is actually pretty cheap if you use it just a little bit. It only becomes expensive if you start to use it a lot. But it costs something like 60 cents per hour, 60 US cents per hour, or 40 cents, depending on which computer you use. So that's not too bad for educational purposes. So I'm going to do this on Paperspace. You don't have to, later on, you don't have to use Paperspace at all for this. You can use Google Cloud Compute or Amazon, or, as I said, if you have access to a computer, maybe the school has computers that have, GPU resources. But basically, this is just, I'm using Paperspace because it's very convenient for educational purposes. So I'm going to sign in, and yes, sign in. And I'm going to take you through both a tutorial of the relevant code bases, but also a little tutorial of Paperspace itself. So Paperspace is it's basically a cloud computation service that lets you spin up computers in the cloud. And I already have one over here, but I'm going to launch a new one. And this is the console. And once you've put in your payment information, you can create new machines. And it bills you to keep the machine, I think $5 US a month to just have the machine, if it's off, basically. And then per hour of usage, it's something like 40 or 60 cents, depending on the instance you get. You can also get really cheap ones that are like 1 cent per hour, but those don't have GPUs, so they won't really be good for our purposes. And you have to be careful to remember to turn it off, because if you leave it on, overnight, as I have done like multiple times, you'll, there's no sympathy for forgetfulness. There is an option though to have it turn off if you idle automatically, so that's just something, if you're a forgetful person, you might want to use You might want to use that. So basically, the way this would work through the console is that you would click New Machine, simple enough, and then you would choose a region, and more or less you can choose the region that's closest to you. They just have 3 data centers, and all of them are pretty far away from us. I guess the West Coast might be the best one for us right now. And then you would go into the templates. Now so they let you now customize the machine. Do you want Windows? Do you want a fresh installation of Linux? And what we're actually going to do is go into their public templates folder. And when the first time you do this, you're going to get a message that says these are not available to you. You have to actually request access for them, which is pretty easy. You just give them a message, what you want to do with them, or if you're taking a workshop or something, and they usually take a day or so to grant you access. So you do have to do that in advance. It's not particularly strict. I've never heard of anyone getting turned down. I think they just use it to avoid, like spam or whatever. So the template we're going to use is the ML in the box template, which is one of their built-in templates. A template is basically like a copy of a machine. It's like a frozen computer with everything on it that was made, for that template. So it has an operating system, has software installed, and has data. So, and you can create your own templates, which is really, really nice. So then, if you create a template for a machine, you can always spin one up when you need it. And they have a few different templates, and I'm going to choose the ML in the box. There's 2 of them, one for Ubuntu 14 and one Ubuntu 16. I think we might as well just do the Ubuntu 16, but either one of these should work. And ML in the box is a template that they have on Linux, which has already basically all of the relevant stuff installed for us. So it has TensorFlow installed. It has Cuda. Cuda Toolkit is a software by NVIDIA that basically does GPU acceleration of parallel computing for things like machine learning and VR, and it's made to work specifically for NVIDIA cards. NVIDIA has kind of got the market on us right now, so it's kind of like you'll see Cuda Toolkit is requested for a lot of the GPU stuff. And it can be a little bit of a challenge to install if you've never installed things like that before. So this kind of takes care of that already for you, which is a nice feature. So I'm going to actually select ML in the box 1604, and then choose a machine, and then basically the template lets you choose either we have to do the 65 cents per hour. You could do the 90-cent per hour, which has a little bit more. A better GPU, a faster GPU, but we'll just stick with the cheaper one. And then say, okay, like 100 gigabytes, that costs $6 a month. So, and then it'll cost 60 cents an hour, so it's not going to be too bad for us. So I'll have one machine. Okay, we can call it CityU. CityU. And default network is fine. There's only one thing there. And then I like to use the public IP option, which will let us interface with the computer through like conventional networking means. If you don't have the public IP, you can only interface with the computer through Paperspace, which is a little bit limiting. So I'm going to show you the way that I like to interface with them, which requires a public IP. And then and then the payment info, and then that's it basically. So now I'm gonna go ahead and create the instance, and basically it'll come up here in a second, and then it takes usually a few minutes to provision and allocate. What's happening right now is that they receive a request from you to create a new machine, and now it's actually allocating all the resources on their side that they need to give you the machine. It'll take it'll take just like 1 or 2 minutes. And then what will happen is you receive an email, and it'll give you the IP address of the machine and also a temporary password. And the password is what you use to access the machine. The password is different from the password on your account. It's the password for the machine. You know how like when you have your computer has a password, this computer also has a password. So they are going to send me an email, And I'm going to just, instead of pulling up my email on the screen here being recorded, I'm just going to pull it up on my phone and so that I have my password. It's just going to be a random set of characters, basically. And just hang on, I'll be there in a second. Okay, so ready. So it sends you an email, it goes, your new paperspace machine is ready. So I'm gonna click into the gears icon over here. And you could, if you wanted to, open the desktop. So like this is kind of their cutting edge feature. If you click open desktop, it'll actually take you to the desktop of the computer itself. So it's like a computer within a computer that you're browsing. Okay, but it tends to be a little clunky. I mean, it's pretty awesome that you have this feature, but it's too clunky, I find. So I like to interface with it using other means. And so I'm going to go back to the console, and I'm going to go to the following. I'm going to say open terminal, and this will actually open the terminal. Actually, let me not do it that way. I'm going to do it differently. Okay, so I'm going to use my own terminal. So you could use their terminal or your own. But I should mention, for people who are on Windows, you'll need one more piece of software, because on Windows, so the way we connect to the remote computer is using what's called SSH, Secure Shell, and SSH doesn't come on Windows machines because Windows insists on doing everything differently. So you have to download like an additional piece of software which runs which allows you to have basic shell commands. And the one that I know works pretty well, that a lot of people use, is something called Commander, or CMDER. So CMDER is like a shell, with Linux, like basic Unix commands that you can download for Windows. So this is what you would need to run what we're about to run. Otherwise, if you're on Linux or on Mac, you can just use the terminal. So basically, I'll go SSH, and this is how to connect to the computer. So I'll go SSH, and then paperspace at, and then you see where it says public IP? I'm going to copy that. You can just click on it, and it'll copy it, and then put that there. That's the public IP address. And it goes, can't be established. Do you want to connect? Yes. And then it will ask me for my password, and I'm going to read my password from my email, and it's basically, so when you write the password, it doesn't actually put the encrypted characters on the screen, so it doesn't look like I'm writing it, but I am. So just a moment. GT 7H4. Okay, so now I'm inside the machine. So this is like being inside of a normal Linux or Linux terminal. So basically, like, I can be like, where am I? PWD. So we're inside of home paperspace, right? You can see what's inside of home paperspace. We have documents and desktop and, like folders, home folders. Except I'm inside of another computer. So if you've never done this before, this is like rule number one of being in any sort of IT, being able to connect to another computer. And now what I'm going to do is I'm actually going to change the password. So it's because the password is some random string of characters, and we'll need it a few times. So rather than, like, I'll just make it something easy. So you can do that using the command sudo passwd. Sudo means administrator privilege. So I go sudo password paperspace, and then it'll be like, give me a new password, and I'm going to make the password CityU. CityU. And the password is now CityU. So now what I want to do is the way that I like to connect to the machine is using something called Jupyter Lab. And I'm going to show you what Jupyter Lab is in a second. Jupyter Lab is a really, really amazing, awesome new software. It's only actually about like 1 or 2 months old right now. It's been in beta. and it's based on software that's existed for a couple of years called Jupyter Notebook. And we've already, I think, briefly touched upon these. So we used the Jupyter Notebook yesterday to do the neural synthesis, except it was it was Google's version of it. So like Colab is basically like a fork of Jupyter Notebook. These are the originals. And the way that I'm going to do that is to launch a Jupyter Lab server. So basically, this is what I'm going to do. I'm going to say Jupyter, that's spelled with a Y, Lab. And then if I just launch Jupyter Lab, it would launch a browser inside of this computer. But the thing is that, of course, like we don't have access to the screen pixels right now anyway. And so instead, I'm going to connect to it from my computer. So here I'll just say, don't launch the browser, no browser. And now it's going to say, okay, we're making this notebook for you. And then it goes, okay, now you can go to this address and access the notebook. But here's the thing, I can't go to this address because remember, this is the terminal to a computer that's in California somewhere. Not this computer. So localhost does not refer to my computer. So instead, I'm going to create a tunnel where I connect to this computer from mine. I'm going to start a new terminal instance, and I'll go SSH, and then -NL 8157 by convention is like just a port number, local port, and then localhost 8888. This matches localhost 888 matches this. And then again, paper space at my URL. And then it's going to ask me again for the password. Now I've changed the password to CityU. And then basically nothing happens. And that means we can now go to our browser and go to localhost 8157. And this is Jupyter Lab. And it's saying, well, you need a password or a token to get inside. This is a simple security mechanism. Where is this password or token? That's right here. See where it gave it to us? Copy and paste the URL. Here's the token right there. So I'm going to copy that. Put that in. And now I'm inside Jupyter Lab. Jupyter Lab is beta software, so it has weird bugs like this. Not a big deal. That happens every time. So this is Jupyter Lab. Now, what are we looking at? So I'm inside my own browser, but I'm actually connected over the internet to this computer in California, which has all of the software that we need to run. And the way, so just a little tour of Jupyter Lab. You see we have a basic file system here, like a file explorer on the left. And then you can go into these tabs. This tells you what's running, some shortcuts and stuff. Mainly we like to use the file system. And then whenever you want to create a new thing, like, okay, if there's nothing here, there's this launcher. Launcher says, okay, what do you want to do? So let's say I wanted to launch a Python 3 notebook. So this is I just launched a Python notebook. And now I can be like, I can just write Python code here. So 5 plus 5 is 10, right? So print hello world is hello world, right? Now the cool thing about this is that what computer is executing this code? The computer that is executing this code is not my own. It's the computer out in California. This is a way to interface with that computer and get the results from the computation back. Now we're not going to use this though. I'm going to, let's just kill that notebook, shut down. And what I want to do is, the first thing I'd like to do is show you how to use char-rnn, because that will be really fun. And also because it'll take maybe like 2 hours to get some acceptable results from it. So we'll have some time to like let it train and then do other things and then come back to it. So here's what I'd like to do. I'm going to open a new terminal, and now we're inside the terminal again. Oops. So yeah, let's make that a bit bigger. So you see that I'm inside home paper space, right? And here's what we have. So what I want to do is I want to grab an implementation of char-rnn. I'm going to tell you what char-rnn is. So recall this article. I think we showed it briefly, right? The Unreasonable Effectiveness of Recurrent Neural Networks is a really good article if you want to kind of get a nice introduction to this technique of char-rnn, which we're about to show. Is written by Anjay Karpathy, and it's basically all about how you can train a recurrent neural network, which is a type of neural network that we haven't really talked about, so I'm not going to go into the details of that, although you can read about a lot of it right here. But one thing, the basic thing to understand about recurrent neural networks is that they can operate on sequences of inputs and produce output sequences. So basically, it's a neural network that works with sequences. And there's a type of recurrent neural network called an LSTM, long short-term memory, which has been proven particularly successful for a lot of things. And one of the really fun introductory things you can do with an LSTM is to train a model that on a sequence, on a very long sequence of characters of text. So fundamentally, what the network is capable of doing is, given some sequence of characters, predict what the next character would be, right? So if you have some training set, let's say it's a book, and the book is a sequence of characters, then you can train the LSTM on the sequence of characters in such a way that then later the network is capable of telling you the probability that of what the next character, given some input sequence, is, what the next character should be. And what you can do is you can keep on sampling from it and generating text. So you can make these networks basically, create text that looks like it came from the training set. So like if we train it on the Bible, it'll sound like the Bible. If we train it on Shakespeare, it'll sound like Shakespeare. If we train it on, source code, it'll look like source code. If you train it on XML, Wikipedia, there's all of these really fun examples, and I think I showed you some that people have made. I showed you a dictionary bot. There's lots of neat things that you can do with this. Actually, someone today posted something like they taught it. They gave it infomercial screenplays, and then it generated an infomercial. So this stuff is all over the place, and it's pretty fun and it's easy to use. And I'm going to use an implementation in TensorFlow called char-rnn TensorFlow. TensorFlow, yeah. So if we go to char-rnn TensorFlow, this is the repository we're going to use. You can just Google char-rnn TensorFlow and you'll find it. I'm going to make this a bit bigger. And what I'm going to do is I'm going to take this repository and I want to download it. Instead of downloading it as a zip, I'm just going to clone it. So you can use Git to clone source code repositories. So I'm going to take this, copy that, then go back to my Jupyter lab, and I'm going to git clone. Okay, so now you see that after a bit, you'll see that char-rnn TensorFlow has shown up in our file system. I literally copied it from the internet, and we can cd into it, and there we have it. Right, so this is what it looks like. Your data, log, save, and so on. Now, so it comes with a basic example using what's called Tiny Shakespeare. And that's basically a text file that contains the entire works of Shakespeare. So we can look at this. So here is a big text file that has all of Shakespeare's works. It's a little hard to load. This is just a big, long text file with Shakespeare, actual Shakespeare. Now, Shakespeare is like a good hello world, but we want to do something more interesting. So what I like to do sometimes in my workshops is try to come up with an idea for something that we can download. So here's the criteria. We need a text file that's at least 1 megabyte. And ideally more, ideally 5 megabytes, right? So the book of Genesis, I think, is 1 megabyte, I think. So What's your favorite long book? Like, let's get some suggestions that you can get online. So like I'll just give you a few examples. Like in my last workshop, someone called out 50 Shades of Grey. And we downloaded 50 Shades of Grey, and it turned out to be roughly 1 megabyte, maybe a little bit short. And you could find the actual raw text of the book on Google search. So that was fun. Sorry? Ulysses, yeah? We could do that. Okay, so the Odyssey, right? That's the same thing. Oh, okay. I was thinking Ulysses, right? That's the Odysseus, right? Okay, so we got one. Well, okay, so like let's get some candidates. So Ulysses, James Joyce. Any others? Who else has something funny? Like this is. So it doesn't have to be a book either. It could be like, like okay, I think you could find State of the Union addresses, like speeches by historical figures. Should we just do Ulysses? 50 Shades of Grey was such a great idea because then it started. Well, it was very suggestive, I guess. Or like Harry Potter or something like that, you know. No one for Harry Potter? Richard Branson book?
Yeah, that might be.
Which one? It's a lot of funny ones.
Yeah, I can't remember. Well, I don't know if you can find it.
Something with like a very distinctive style, right? Like something.
It's called Screw It, Let's Do It by Richard Branson.
Screw it, let's do it.
Yeah.
This is all about Richard Branson and Bill Bryson.
Something that's like going to be familiar to everybody. Should we?
You can't beat Harry Potter.
I get right. Well, but then, yeah. Should we do? Should, what's that? Art of the Deal? Wait, that's Trump. Oh my God. How big? How long is that?
How about Time Machine, H.G. Wells? I started with that.
Yeah. I'm kind of liking the Art of the Deal idea. Sorry? Wait. Yeah, it is. It is, isn't it? Here's Trump in action. We see how he operates day to day.
That's what I'm saying. There's transcripts of all these speeches and interviews, which are more this thing.
Right, yeah, exactly. But I don't know if I, like, okay.
Maybe like a collection of jokes.
A collection of jokes. That's interesting.
You're trying to be funny.
If it has to be, what? I don't want to get lost on the internet right now.
What about the Umberto Eco?
I've done that one. That one. Sorry.
Umberto Eco's Name of the Rose. The Name of the Rose by Umberto Eco?
See, we're getting really like really niche. Like, you know, maybe we should just. What's that? 2001.
It's based on the sequel.
Should we take a vote? All right, we're gonna do a vote.
There's all of Trump's tweets.
Sorry, what's that?
It's a GitHub with all of Trump's tweets
Oh yeah.
up to 5 months ago.
Maybe we should do that. Is this it? This one?
Well, the one I found is mkearney/Trump chicks.
I see this one right here. Because it is quite distinctive, right? But the question is there a text file? CSVs. Sorry? Should we do this one? Let's just do this, guys. It's too distinctive. It's like we're getting a lot of niche. It is an example, right? So I'm gonna let's first of all let's see how long this is. Okay, actually,
So on the terminal, I give you the
on my terminal.
on the bigger screen.
What about it? Let's see how first of all how long this is. 4.8 megabytes. That's pretty good. Oh yeah. It's how do I zoom in? That's perfect, right? Kirk and Hillary. It's perfect. Okay, so here's what I gotta do. We gotta turn this into a text file. So we'll copy this whole column. It's all here. And put that into here. That might take a while. Not too bad. Okay, that looks like a bunch of tweets. Perfect. Okay, so let's save this. And yeah, I'll put it right there. Trump. And now I gotta upload it to the Jupyter Lab instance, and that's gonna take just a second. This is taking its time, of course, because there's like 100,000 lines. So let me just, while it's doing that, I'm gonna go back to here. And basically we just need to create a folder for it. So there's this folder data, we can just put it in here. So I'm gonna make a new folder, a new folder here called Trump tweet. And then we're going to upload it here, and you can actually just drag and drop once it's actually ready. So I got to go to here. Isn't that where I just saved it? Still saving, I guess. Well, that's not ideal. This didn't. Well, how many times has Trump tweeted in the last 6 years or whatever? Probably quite a. Okay, I think there was like 100,000 lines in here. That's why it's taking a while to save. And it sure looks right. Great to be back in Arizona. Okay, this is saving a while, so like while it's frozen, let me just tell you how to use it. So hopefully it'll be done saving by the time we're done looking at it. So like the way that you can, and this is kind of a general tutorial. Like if you find a repository on GitHub that does something really, really interesting, how would you figure out how to use it, having never used it before? Well, we can look at the documentation for the, where is it? So.
What do you get by using the browser instance there?
So for example, I can easily upload and download files, and you can do that with like curl or something, sorry, or SCP, sure. But this is kind of nice because I can just drag and drop things. Not a big difference, but yeah. So yeah, you could do everything, all of this through the terminal. But
What you get by going to localhost and then tunneling to, why don't you just put the IP directly the paper space or the IP on the.
oh, but that won't connect to the, because it creates a like it creates the Jupyter Lab server locally. The server is local, and then it has a way of interfacing with it, but you have to interface through a tunnel. So this thing is sure taking a while to upload, which is not good, but anyway, if we look at char-rnn TensorFlow, it says, okay, to train it, basically you can go, you say, if you want to know what you need, you just go Python train help. So this will tell you what all the parameters are. So I'm gonna go back to this and say Python train .py -- help. So basically, Python train.py will start the training, and these are all of the parameters that are available to set it up, right? So the ones that we absolutely need are data directory. So what directory contains the input text, and we need savedir. That's what the directory that will save the model, where we'll keep the model, is located. And all of the rest are kind of optional for us, but I'm going to change a few of them because I happen to know a few things about it already. And you can use the default settings, and it'll train for just like a few minutes, basically. So this is not going well. I've been trying to save this thing, and it's not ready yet. So let's do a backup in case we can't find. It's too short. It's going to be too short. How about so we can, okay, well, we can use the Ulysses, right? That was our first. So we can grab this at least. So I'm just going to copy this because it says .text, but it's actually an HTML file, so I have to copy it.
You could double get it directly from Project Gutenberg on the machine and Microsoft.
What was that? Sorry?
You could double get it from the Project Gutenberg.
Oh, yeah?
Yeah, they link directly to these files.
I suppose we could also just look at where can we find it? Books by James Joyce. Is this right? You know what I'm looking at? Ah, plain text right here. Perfect. Is this what I think it is? Yeah. Okay, cool. Okay, so here's what I'll do. I'll cd into data, make mkdir to make a new folder called Ulysses. There's Ulysses. I'll cd into there, and I'll do wget. Wget will retrieve any URL and download it to your local file system. So there, I just saved it, and now it should show up here. Now, by default, this repository looks for a text file called input.txt. So let's just rename it to input.txt. So now I'll go back to the main folder, and basically we'll do Python train.py, and then basically we say dash, well, let's remember what so we need --data_dir, so that one we definitely need, and we'll say data Ulysses. That's the data directory. That's the folder that has our input file. And then also I want to change the number of epochs. So epoch is how many times does it cycle through the entire data set to train. So how many times will it read the book? So I would like for it to read the book more than 50 times because actually this will go very quickly. So I'd like to take this and let's make this 200. And let's also make the network bigger because it actually starts with a very small size network. So we'll say num layers is, it says 2, but let's use 3. And we'll also change the RNN size, which is right there. RNN size, it's 128, but let's make it 256. And otherwise, we can keep everything else the same. Maybe make the sequence length also bigger. Let's make -- seq length 100. And then the save directory will just be saved. That's the default. So we'll just keep it at that. So are we ready to begin training? Still don't have the Trump tweets? No, I guess not. Okay. So we'll just go with Ulysses. So I'm gonna hit go, and it'll take a little bit while to load up TensorFlow. So it just gives us a bunch of junk, reading text file. And then once it instantiates the model, it'll begin to give us updates. Usually it takes a little while to get going, and there it goes. So now it's training, and it is giving us an update on every single batch. So it does a batch of characters, and it's going to do 62,600 batches. So we can figure out how long this is going to take because each batch is taking, looks like roughly 0. Let's say 8 seconds. So 0.08 seconds times 62,600. That means it's going to take roughly that many seconds. There's 3,600 seconds in an hour. So this process will take roughly 1 hour and a half, which is perfect. So we can check on it later. So what I'll do is I'll leave this going. And now we'll move on to just keep this in the back of your head. We'll return to it. We'll see what it's done once we've trained it for a little while. And in the meantime, I'm going to start a new thing, which is I want to show you how to do neural style transfer. Yeah?
Do you have any tips on how to test the training? I mean, I've been playing with this for a while, and it's always to me trial and error.
An error? You got to...
Trial and error to get like...
Oh, sure, yeah.
Changing parameters and
Yeah, I mean, well, one thing is like it's helpful to, so you can always like pause training and observe what you have, and then keep, like once you have an intuition for what the parameters do, then you can modify the parameters as you train because you can always reinitialize. So like the parameters that control the training, there's various trade-offs to them, right? So what I just changed, I made the RNN size bigger. I basically gave it more layers and more neurons. The more complex you make your neural network, then the better it should be able to model the thing that you're trying to model. The danger of that, though, is that it might overfit, right? So if you make your model too big, it can just basically begin to memorize parts of the data. So there are ways of doing what's called regularization, which try to minimize the amount of overfitting you have. So there's different kinds of regularization. I'm not sure which ones are implemented by this thing right here. Like for example, you could do L2 regularization. You can do dropout. These are all technical terms, so I don't want to go into them very deep right now within this workshop, but those are things that you kind of pick up as you go. And then also you can, so also the sequence length is like the training parameters, so like the size of the batches and the sequence length, those also can complicate the model. Basically, if you feel that you're overfitting, then you have to try to introduce regularization of some kind. It's a lot of it really is sort of more of an art than a science. So the answer is just keep trying. Also give it more text. So another thing is that like 1 megabyte is the bare minimum. 5 megabytes is better. 50 megabytes is great. And also typically you really need to train for like a day, 2 days. This we're going to be training for just an hour and a half, so it's not actually going to end up being that good. It's not going to sound that good, but it's just going to be a demonstration of, you'll get some results. So, yeah. It's a game of trade-offs. Anyway, while this is training, I want to show you neural style, which is something else, and we'll come back to this. And neural style actually is, so first of all, like I'm going to have to create a new paperspace machine because the GPU is taken up right now by training this thing, so we can't use the GPU for everything at the same time. So I'm going to actually just create a new machine. So let's go back to paperspace. I'm going to go to my machines, my console. I'm going to launch the console. And I'm going to create a new machine. So same thing, California, public templates, ML in the box, this, and that. Okay? So this is creating a new machine. It's going to come up here in a second. It's just called new machine 1. I didn't give it a name. Okay, so provisioning, new machine is creating. In the meantime, I'm just going to go back to terminal. I'm just going to do everything exactly the same way. While it's provisioning, I'm gonna go to the neural style repository, which is, now there's a few repositories online that do neural style transfer, and I like this one. This is actually basically the first open source one or the second open source one, the first one that was really good that came out, and it's based on Torch, not TensorFlow, and I really like this one, but there's others that you can look up. Like if you look up neural style transfer, you'll see that there's a handful, maybe 3 or 4 good repositories. Most of them are in Python that run this. Now we're going to be using it from the terminal, so it doesn't really matter that it's in Python or Lua. But I happen to like this one, so I'm just going to show you. But they all fundamentally work basically the same way. So this is taking a while. Sometimes it takes longer. Oh, there it is, okay. Okay, so now I'm going to go over here. And I'm going to grab my password. And I'm going to connect to it. So SSH, paperspace at public IP. Yes, and then password 9Q. Okay, so now we're in this machine. Want to quickly change the password again. Okay, so now I'm going to start a lab here again. And again, go into here, SSH-NL. I have to use a different port because 8157 is occupied. So I'll use 8158, 888, paperspace at this. So this is there. I'm going to grab that token, copy, launch. So now I'll open up oh, what did I do wrong? Oh, oops, right. CityU. Okay, token. And now I'm inside a second machine. So we have two machines now that we're interfacing with. Now there's a one issue is that I discovered this the hard way during a workshop like a few weeks ago, is that the ML in a box template, which comes with Paperspace, is actually has a slightly broken torch. So I figured out how to fix it, and then I made a little online instruction sheet that we can look up. So basically, you will just go to gist.github.com/Gene Kogan, and then go to this fix.sh, and we basically have to run all this. So hang tight. I'm gonna go in here. I'm gonna start a terminal. I'm gonna run that. And then where is it? Basically have to install a few things. Luarox is a package manager for Torch, which is giving us all the libraries that we need. And this will actually take like a few minutes to do, so while it's doing its thing, we will go ahead and here we go. So this takes a second. Now I'm going to run this. Now this is going to take a little while. So in the meantime, while it's doing this, I'm going to actually start a new terminal instance here. And I'm going to grab neural style. So here's neural style. Want to clone it, copy. Okay, so there it is. And now I'm going to go into it, CD. And then if you read neural style, says, okay, this is Torch implementation of all this, tells us what it does. So it takes, this is what neural style does. It takes two images, a content image and a style image. So here, for example, the Starry Night, Van Gogh's Starry Night, is the style image. And the content image is this picture of Stanford. And then it will regenerate the content image in the style of the style image. So here's the output, which is this in the style of this. So everyone gets the basic idea, right? So this tells you, if you read the documentation, it'll tell you everything like about what all the parameters do and what they mean. Documentation is very like nice and easy. And the first thing we have to do is download a model. So after installing the dependencies, you need to run the following script to download the model. I'm going to do that now, even though the dependencies are still installing, because this will take a while also. So I'm going to run sh models, download models. And what this is doing is it's saving to my disk a neural network called VGG 19. And VGG 19 is a trained neural network that's about 2 or 3 years old, or 3 or 4 years old, which does very, very good image classification. And it's actually going to be used in the process of style transfer much the same way that we used it, we used the Inception network yesterday in the process of doing Deep Dream. So the idea is that you use the network as a sort of analytical tool, where where you measure the activations and then you are trying to optimize some particular objective. And in the case of style transfer, it's very similar in a sense to Deep Dream, but the objective is slightly different. The objective in Deep Dream is to basically achieve a certain desired set of activations. The objective in style transfer is, I think I have well, this is not super informative. Okay, well, I'll kind of give you an idea. Like basically there's a loss formula, and we're trying to minimize the loss, and the loss is the sum of the content loss and the style loss. So the content loss is how different the content is between the content image and the output image, and the style loss is how different the dissimilarity between in the style of the style image and the output image. And then the content image, I know this formula looks super complicated, but it's actually expressing something very similar and very simple. The content loss is the difference in the activations. So like the neural network has all these activations, right? And then the assumption is that two images, if they have similar content, they will have similar activations, right? There's a dog neuron, there's a face neuron. If the two images have dogs and faces and everything like that, they'll have similar activations. And so this is just doing a subtraction between them. And so this content, that's this right here. The style loss is a little bit more complicated. So I'll just summarize it for you. The idea of the style loss is that there's also a difference of two things, but instead of the difference between the activations, instead of the difference between the activations directly, there's this sort of, there's a computation of something called a gram matrix. And the gram matrix is, for a single image, all of the correlations of its individual activation layers, or the correlations of its activation maps. So like, okay, you have, well, this is hard to explain. It's like, okay, imagine you have all these activations in one of your images, right? And the activations are per pixel. So you can measure the correlation between two activation maps. So the gram matrix is literally taking every single pair of activations and then taking their correlation, and that becomes a number in the gram matrix. And then it's the same thing. It's just the distance between them divided by some normalization factor, and then that's it. So I know that's like a very hand-wavy explanation for what style transfer is, but basically it's just all math and it works magically. No one really understands like why this should work, but it works. It works great. So that's the point, anyway. So let's hope that this is still. Oh yeah, this takes a little while to download. Sorry. I know this week has been full of a lot of hand-wavy explanations, and it's just like I can't get out of that pattern. It's like I want everyone to understand everything at the most granular level, but I also want to make progress, and so I have to like balance these two competing objectives. When I first read it, like it didn't make any sense at all to me. It's the kind of thing that like when you come back to it a few times and read it once and read it the second time, read it the third time, maybe get an explanation from different sources, it'll start to make more and more and more sense. That I can assure you. In any case, this is still installing all of the stuff that we need. So this is a process that takes a few minutes. It will be done like once it's done. You don't have to do it again. It's just this is like a thing that's just a problem with this template. But you can save the template. You can close the computer, and you'll still have access to it. You can always open it again, and you won't have to do this process again. You'll have everything ready for you. Okay, yeah, that's done now. Now there's just a few more things I have to, yeah, we already cloned it, download the models, and then that's it. And I think we just have to do this too. How are we doing on that? Looks like we're about a quarter of the way through. Okay, so let's quickly do that. And now I'll go to neural style. Okay, so now all of the software is installed. And there's the model is still downloading, so now we have to decide what we're going to do the style transfer on. So my favorite thing to do is to take a picture of you guys, and we'll do a style transfer of you. And I need an idea for a good style image. Okay, so I can't get all of you in frame, so I'm gonna do my best, but so something like that. Smile. Okay, now I'm going to send this to myself. Hang on a second. And oh, I can't send this to myself because what's, oh, you see it, you're all seeing yourselves? Okay, I just wanna, hang on. Oh, because, see, they're all like, oh, there we go. I found myself. Got it. Okay. So now I'm going to upload that. It's in my downloads. So here's that. So there you guys are. I'm gonna upload this here. You can just drag and drop it. Okay, it'll take a little bit of time. There it is. So now I have it on this machine here. Now we need some sort of a style image. Okay, now we can have some fun. Like, all right, what do we want to use as style? What's that? Where's Wally? Where, you mean like the movie? Where's Waldo? Where's Waldo? So we want to use one of these? We can do that. Like, okay. Wally, really? For what, American audience? How's this one? This one's a little better, right? Okay. All right, let's do this. Find out. So I'm going to, and let's actually just go ahead and copy the image address, and I'll just wget it. Okay, so there we are there. And wget. And there it is. It's called max res default. Let's rename it to Waldo, or Wally. W-A-L-L-Y? Okay. Move max res default. Wally.jpg. Okay, so now the thing is, like, the model is still downloading. It'll take another 13 minutes, but that's okay because we have to still go over how to generate this, which is actually like really, really simple. So here's how it works. So if you look at the commands here, you see it goes neural style.lua, style image. Actually, so I think maybe a good idea will be to just like let this, okay, so we're still downloading the model and it'll take another 12 minutes. So perfect time to take a quick break. So we'll do a quick break and then when we come back, we'll do style transfer. Okay, so yeah, like 5-10 minutes.